All right, good morning. Today's interactive problems will be on calorimeter and it's going to consist of the problems I gave you to solve. We can go through together and then you see how problems are being solved.
Heat flow in a calorimeter
The specific heat, C,
of a substance can be determined accurately by measuring temperature changes that occur when heat is transferred from the substance to a known quantity of water at constant pressure P.
C water, equals 4.18 joules per gram per degree Celsius. C water equals 4.18 joules per gram per Kelvin. The specific heat values are the same when expressed as degrees Celsius or Kelvin.
Delta T equals change in temperature. The change in temperature will be the same when expressed as degrees Celsius or Kelvin. The sum of heat changes within a given system is zero. Thus, Q substance plus Q water equals 0. Q substance equals mass substance times
C substance.
delta T. Delta T equals T final minus T initial. Similarly, Q water equals mass water times
4.18 joules per gram per degree Celsius.
times quantity T final minus T initial. Hence, plus equals 0. Example: a calorimeter contains 125 grams of water, and its initial temperature was 21.0 degrees Celsius. A 35.0 gram metal was heated to 99.8 degrees Celsius and dropped into the calorimeter. The final temperature of water and metal is 23.1 degrees Celsius. Calculate the specific heat of the metal. Mass substance equals 35.0 grams. T final equals 23.1 degrees Celsius minus T initial equals 99.8 degrees Celsius equals negative 76.7 degrees Celsius. Mass water equals 125 grams.
4.18 joules per gram per degree Celsius.
T final equals 23.1 degrees Celsius minus T initial equals 21.0 degrees Celsius equals 2.1 degrees Celsius. Negative 2,684.5 times
C substance.
plus 1,097.25 equals 0.
C substance equals 0.41 joules per gram per degree Celsius.
Click on the table. It gives the specific heat values of several substances.
All right, these are the specific heat capacities of different substances. These are constants that need to be given or need to be known before you solve any problems. You don't have to memorize this. You do not need to memorize this. They are substance constant that will be given to you.
Example: A calorimeter contains 85 grams of water and its initial temperature was 26.0 degrees Celsius. A 28.0 gram metal was heated to 75.5 degrees Celsius and dropped into the calorimeter. The final temperature of water and metal is 27.1 degrees Celsius. Calculate the specific heat of metal.
All right, let's look at the problems. Try to see if you can figure out the mass, the final temperature, and its initial temperature for the metal, the mass of water. Then you get your T final minus T initial for water. All right, you must have paused the video so that you can see if you can get all these values substituted into this formula at the top. So let's move on. You should get something like this. Then you divide this by that to get your final answer. And please make sure your units are consistent. Get your units at the beginning and make sure you cancel them out if you need to be cancelled so that you know exactly what you have at the end. It is very easy. Just make sure you write the units from the question and then you go along with the unit because unit counts. If you don't give units, sometimes you may not get your credits. All right, so if you solve this problem, you're going to get 0.286. So just round up to 2 decimal points to 0.29.
Example. A calorimeter contains 100 grams of water, and its initial temperature was 22 degrees Celsius. 35 grams of a metal of specific heat capacity, 2.25 joules per gram per degree Celsius, was heated and dropped into the calorimeter. The final temperature is 26.5 degrees Celsius. Calculate the initial temperature of the metal.
Right, this is interactive. You need to supply these values from the question. There you go. So if you do the collection of the data from the question and then substitute into the long formula equation, then you will get something like this. You can see that the grams and the grams all cancel out from both sides. All right, we are on the last stage of getting our temperature final minus initial equals to negative 1880 joules over 78.8 joules per degree Celsius. So you can pause the video to solve this problem and write your answer in the box. All right, the answer will be negative 23.9 degrees Celsius.
T initial equals.
So what is your final initial temperature? Because this was the final minus initial equals to negative 23.9 degrees Celsius on the other side of the equation. So to get your T initials, you solve this problem. All right, the answer is 50.4 degrees Celsius. Question 2.
Enthalpy is a chemical energy represented by the symbol H.
All right, the next is enthalpy. That's topic 6.8 to 6.15.
Enthalpy, H, is expressed in joules, J, or kilojoules, Kj. The enthalpy change, delta H, for a chemical reaction is expressed as delta H equals H products minus H reactants. H products is the enthalpy of products. H reactants is the enthalpy of reactants. The enthalpy of reaction, delta H, is the heat of reaction, Q reaction at constant pressure P. Consider a chemical reaction. The chemical equation is balanced and it shows the enthalpy change associated with it. This type of chemical equation is called a thermochemical equation. The negative value of delta H indicates that the thermochemical reaction is an
What is that? Is that exothermic or endothermic reaction?
exothermic reaction. Delta H equals negative value or delta H less than 0. Consider a chemical reaction. The positive value of delta H indicates that the thermochemical reaction is an
What is
endothermic reaction. Delta H equals positive value or delta H greater than 0. Thermochemistry. Rules. Rule 1. The magnitude of delta H is proportional to the amount of reactants or products. Consider a chemical reaction. According to this reaction, 2 moles of H2 reacts with 1 mole of O2 to produce 2 moles of H2O. And the amount of energy released is 483.6 kilojoule. Therefore, for 1 mole of H2O produced, according to the rule, delta H equals negative 483.6 kilojoule divided by 2 equals negative 241.8 kilojoule per mole. Example. Consider the following thermochemical equation. Equals negative 241.8 kilojoule per mole. Example. Consider the following equals negative 241.8 kilojoule per mole.
I was trying to go back to check why do we divide by 2? We divided by 2 because this total change of heat produces 2 moles. And we want to have 1 mole of water. So that means if 2 moles of water produced needed negative 483.6 kilojoules, then 1 mole of water would be divided by 2. That's how we got the 2 from, just in case you're confused. All right, let's move on.
Example. Consider the following thermochemical equation. Calculate delta H when A 1.00 grams H2 reacts and B 2.50 liter of H2O gas at 100.1 degrees C and 760 millimeter mercury is produced. A mole N of H2 equals 1.00 gram divided by 2.00 gram per mole equals 0.500 mole H2. Delta H equals 0.500 mole H2 times negative 483.6 kilojoule divided by 2 mole H2 equals negative 121 kilojoules. B. Calculate mole N of H2O using the ideal gas law. PV equals nRT. P equals 760 millimeters mercury equals 1.0 atmospheres. V equals 2.50 liters. N is to be calculated. R equals 0.0821 liter atmosphere per mole per Kelvin. T equals 100.1 degrees C equals 373.25 Kelvin.
Remember, when you are working with gas law, the temperature must be in Kelvin. Don't forget to convert to Kelvin by adding 273 to whatever you are given here as a Celsius converted to Kelvin.
N equals
Remember, your N here equals to PV divided by RT. When you make the N subject here, that's how you got these values from. Pressure times volume divided by the R, which is a constant, times the temperature. All right?
0.0816 mole H2O. Delta H equals 0.0816 mole H2O times negative 483.6 kilojoule divided by 2 mole H2O equals negative 19.7 kilojoules.
Now I want you to pause this video and go over it again step by step. You can pause and rewind so that you can make sure you understand every step and every detail of it.
Example. Consider the following thermochemical equation. Calculate delta H when A. 6.0 grams O2 reacts and B. 1.50 liter of O2 gas at 26.2 degrees Celsius and 1.0 atmosphere is reacted. A. Moles N of O2 equals mass in grams molar mass grams per mole.
What is the molar mass of oxygen? 32. So when you divide 6 by 32, get 0.19 mole.
.19 moles O2. Delta H equals 0.19 moles O2 times negative 1,273 kilojoules divided by
You will get 1.5 mole at the bottom, and then when you solve that problem, what would I give you?
equals
All right, the delta H is negative 1.6 times 10 to the second power kilojoules.
B. Calculate moles N of O2 using the ideal gas law PV equals nRT.
All right, these are the data for PVNRT. Then making N the subject of the formula, you get your N equals to these values. Once you plug in these values in your calculator, you should get your N equals to 6.1 times 10 to the negative 2 mole per oxygen. Then delta H will be these values over 1.6 mole. And the answer is negative 52 kilojoules.
Thermochemistry. Rules. Rule 2. Delta H for a reaction is equal in magnitude but opposite in sign for the reverse reaction. Consider a chemical reaction. According to this reaction, 1 mole of hydrogen reacts with 1 mole of chlorine to produce 2 moles of hydrogen chloride, and the amount of energy released is 185 kilojoule. According to the rule, according to this reaction, 2 moles of hydrogen chloride break down to form 1 mole of hydrogen and 1 mole of chlorine. The amount of energy absorbed is 185 kilojoule. Example: consider the following thermochemical equation. Calculate delta H for. Reverse this reaction and apply Rule 2. Delta H equals 185 kilojoule. The problem asks to calculate delta H for 1 mole of hydrogen chloride. Hence, apply Rule 1. Delta H equals 185 kilojoule divided by 2 equals 92.5 kilojoule per mole.
Any question on this? It should be straightforward because you're applying rule number 1, which is the number of moles produced is 2, but you want to find 1 mole of that substance, which is HCl. So you're going to divide by 2. Divide the delta H by 2 to get your number of moles for 1 mole. And because this is a reverse reaction, the sign is going to be negative. Opposite of that sign you had before.
Example: consider the following thermochemical equation. Calculate delta H for. Do we reverse this reaction?
Yes, we need to reverse the reaction. So here you are asked to enter the reverse reaction for this. Get your pencil and see if you can do that now. Your reverse reaction should look like this. CH4 plus 2O2 to produce CO2 plus 2H2O. By what coefficient should the above equation be multiplied to get this? Yes, you multiply by 3/4 to get this reaction. Multiply it by 3/4 or 0.75 to give you this equation.
Therefore, the new equation is. This corresponds to the equation given. Delta H equals negative 890 kilojoule. Hence, to find delta H for 3/4 mole of methane, apply Rule 1. Delta H equals negative 890 kilojoule times 3/4 equals
Remember your answer has to be in significant figures. Instead of writing negative 6.67, you have to write negative 6.7 times 10 to second power.
Rules. Rule 3. The delta H for the overall reaction is the same whether the chemical reaction occurs in one step or several steps. Consider a chemical reaction that occurs in 2 steps. Step 1. Step 2. The overall reaction is.
Now, if you remember this topic, this is like applying the Hess's law. Those of you are familiar with Hess's law. This is exactly what we're doing now. We're trying to combine Hess's law into thermochemistry.
Delta H overall equals delta H step 1 plus delta H step 2. This relationship is called Hess's law. Example: consider a chemical reaction. Calculate delta H for the overall reaction. Look at the first reactant in the overall reaction. Look for the same chemical in the steps. In step 1, sulfur is a reactant as it is in the overall reaction. In the overall reaction, there are 2 moles of sulfur, whereas in step 1, there is 1 mole of sulfur. Apply Rule 1. Multiply step 1 by 2. Since oxygen appears in both steps, ignore oxygen at this point. Now look at sulfur trioxide. It appears as a product in the overall equation, whereas in step 2, sulfur trioxide appears as a reactant. There are 2 moles of sulfur trioxide in the overall reaction as well as in step 2. Apply Rule 2 to step 2 and reverse the reaction. Add all reactants in both steps. Add all products in both steps. Cancel the common chemicals from both sides. This is the same as the overall reaction. Now apply delta H overall equals negative 792 kilojoules. Example: consider the chemical reaction. Calculate delta H for the overall reaction. Look at the first reactant in the overall reaction. Look for the same chemical in the steps. In step 1, carbon is a reactant as it is in the overall reaction. In the overall reaction, there is 1 mole of carbon. In step 1, there is 1 mole of carbon. Therefore, by what factor should step 1 be multiplied? Applying Rule 2 to step 2, reverse the reaction. There is 1 mole of carbon monoxide in the overall reaction as well as in step 2. Therefore, by what factor should step 2 be multiplied? Therefore, the net equation is. This is the same as the overall reaction. Now apply Hess's law to calculate delta H overall. Delta H overall equals Example. Consider the chemical reactions. Calculate delta H for the overall reaction.
All right, I want you to solve this problem and see how you're going to do it. In our next lesson, we're going to start from here so that we see the solution to this problem. All right, it's good talking to you today. I hope you really enjoyed the thermochemistry. Make sure you go over the video step by step. You can rewind and pause and work them out. We see again next period. Thank you for watching. Remember to subscribe to the channel. Just click subscription button. Thank you.